So let's quickly go over what is eBPF. eBPF is, to put it kind of oversimply, an event-based way for us to run custom code either in the kernel or in applications. So there's kind of two axes we can look at: probes, which are the attach points on. We can look at them in kernel space versus user space, and we can look at them in dynamic versus static. So static probes are going to be compiled in. Typically, they have a stable API. They have usually reasonable documentation, although in user space, some of that can vary. And dynamic probes are more about arguments to functions, return values from functions. And so, by name, they are a bit more dynamic. They're better for kind of a quick and dirty, is this thing happening? How often is this thing happening? Things like that. So there are ways to enable unprivileged eBPF. There's limitations to it. I didn't really deal with it, so I'm just going to ignore it. And since we're running user space code possibly in the kernel, we need to make sure that it's not going to crash. And so eBPF has the verifier. The verifier makes sure that, among other things, programs run to completion. So you can't have unbounded loops. All of your bounded loops must always progress towards completion. There's a size limit to programs, and there's a finite complexity limit. Again, there's others, but that's kind of the basics. And while it's out of the scope of this talk, there was a talk given at DEF CON in 2021 about developing a rootkit with eBPF. For my work, I used two frameworks. I used BCC, which is a Python and Lua-based framework, and I used BPF Trace, which is a custom tracing language that borrows syntax from awk, C, and Perl. There are also libraries for Rust, Go, and C++, and I think there's a hardware-based library. I don't really know a ton about that, but there are a bunch of different libraries for attaching eBPF to programs. And so now, what is the Revalidator? I'll try and keep this one brief. There have been so Joe Stringer did a really great talk on this back in 2014. Ilko wrote an excellent blog post about the Revalidator about a month ago. But to put it briefly, the Revalidator is vSwitch's garbage collector. And it does this in two phases. There's the dump phase and there's the sweep phase. During the dump phase, each float is going to get a key and it's going to build a cache. Based on when was this flow last used, some information about the flow key. And then during the sweep phase, it's going to walk through the cache, and it's going to get rid of any flows that are either unused or malformed or just need to be gotten rid of. And these flows are deleted silently, and the Revalidator code is, well, there. So here we have, there it is. Here we have just a little illustration of the mark phase. So we have flows X and Y already in use. Flow Z is new. So we're going to grab a little bit of info from flow Z, and then we're going to add it to the cache. So then later, when we go to the sweep phase, we're going to start by asking, is this key X any good? All right, how about key Y? How about key Z? And if any of those are no good, then we're going to delete them. But importantly, there's no information on why flows are being deleted right now. And there's no notification. And so we have tools that can be used to debug flow creation, kind of. There are existing probes for that. And there's no way to see right now why flows are being deleted. Is it being deleted because it's invalid? Is it because it's not being used? Is it that there's a bug maybe? And this is less important for flows being, and this is kind of a secondary thing, but there's not really very great tooling for parsing what's going on with IPv6 flows. And so this was all kind of done as part of a summer internship. And this was my first adventure with using Git, mailing list dev, so that was a bit of an adjustment. So I started by adding a patch that Aaron sent me that used syslogs to monitor the Revalidator. And as we'll see, this very quickly became unmanageably noisy and just not a good solution. So the first iteration of the probes used or gave just the enum for the reason and a string representing the UFID. And we kind of found that this wasn't very helpful, and so we wanted to pass a struct into these scripts. And well, passing structs into eBPF is a little bit tricky. We can't just include our header files because anything that we include in eBPF has to also pass the verifier. And this is a little bit unsolved. I know that Adrian and Ilko have been working on it. I don't know where they're at on that. But it's a little bit unsolved. So once this flow information is successfully passed into the Python script, then all that we need to do is take that flow apart, parse it, figure out what's going on in the key, and take it apart attribute by attribute. And so let's go through an example. How many flows are going to be created in each of these series of commands? In this first one, how many flows? And are things going to change if we do this sequence of commands multiple times, or is it just going to stay the same? And I want to note that for this test, there's nothing else running on that instance of OBS. So let me switch over. So I'm going to put the Python script that I wrote on one side. And I wrote a little script that just brings the interface down, brings it back up, and then dumps flows. And so I'm going to do that on the other side of the screen. And let's do this one first. So this one, pretty straightforward. We're just going to see that we have a single flow that gets created, and in a few seconds, we see a timeout. So then, how many flows do you think will be created when we bring down the bridge and then bring that back up? So there we have 3. And then this is where things are going to get a little bit hairy. And we start seeing a whole bunch. And so why might we be seeing that is a question that I have not gotten to yet. So this is kind of the functionality of the scripts that I wrote. But I had a kind of a second question, which was, can we there we go. Which is, can we go a bit further? Can we watch all the, so there's a kernel trace point called OBS datapath outcall. It has tons of information in it, but can we write a script that'll watch flows all the way from the kernel trace point to when they're deleted in the Revalidator? And if so, what do those look like? What information can we gather at each stage? And so some potential pitfalls that I thought I might run into is the kernel trace point takes different fields. We don't have access, it's before we've assigned a UFID. And can we map the fields in the kernel probe to the user space probes? And the answer is, let me share screen again. Let me just, there we go. Okay. So I'm going to switch where things are running. And all right, so we're going to start that up. And we'll just do a little, just a little ping. And as we see here, we actually have a few flows I've called. So we have a few flows I've called. I think this one, okay. I can stop that now. So the answer is yes, sort of. We can correlate the kernel trace point to user space in a few ways. I kind of took the easy way and correlated based on the easily obtainable information from the kernel trace point, which can be found at, it's in sys. Where is it in sys? That's a good question. Right. Get that. All right. So we can grab the information from the kernel trace point pretty easily. Correlating it to what's going on in user space is a little bit more challenging, but once we get the information in the flow put probe, then it's smooth sailing from there because we get a UFID, and then we can just use that instead of trying to correlate based on the statistics of the flow itself. So let me pull this back up again. So some future work, some future questions. There are at least 2 new patch sets since August using eBPF probes. I think Adrian wrote one of them and Ilko wrote the other. I'm not entirely sure. No? Someone else did. All right.
It's all Ilko.
All Ilko, okay. And I would love to explore using eBPF for more than just monitoring. It can definitely be used to manipulate the contents of the socket buffer. Can we use that to get some better parsing on IPv6 flows, for instance? So I think that's all. Are there any questions?
Yeah, I guess we'll start if anyone in the room has any questions. I guess I have a question, which is, so what is the status of this work right now? Last I saw, there was a v4 patch that had been posted.
Yep.
And I know there is some kind of back and forth going on about the best way to include some of these structures in, you know, in a built object so that we can use it from our eBPF code or our Python code. Is there any progress there?
I'm not sure if there's any progress on that front. I know that it looks like there's not progress on that, no.
I can elaborate a bit one. So I think we're waiting to see if we can have support to Payhole to get the data structures out dynamically, so on the fly, so you don't have to include them in your script.
Right.
And I think we're waiting on someone to actually do the work to get that from the debug data, because they have optimized the debug data structures to use less memory.
Yeah.
And to use that data directly, you need to reinvert it. So
okay.
we're waiting for that. And then the other thing is I'm still waiting to get time to review your final version.
Yeah.
And then we need to decide how we want to continue. Maybe we want to get the patch in with the data structures there and remove it a bit later. We have to see how we want to handle that.
Awesome. I know that there's like a session later today where people can, you know, maybe work on some things. So maybe that's a good time to. Okay. If there are no more questions, let's thank our speaker. Okay. Our next speaker is me. So I will